All right. I'm Matt Jones, and I'm making an immersive RPG in Godot. And I know it's been a while since I put out a video. I've been really busy with real life and work and family and a lot of unexpected stuff, but I've been working on this, even if it's just a little bit every day. I've been working on it almost every day, even if it's just a little bit. But anyway, one of the things I've been working on is some of the larger videos, but this is a small thing that can be very helpful that I've noticed while working on the asynchronous loading. First, let me get a plug in here. If you want to find out more, you can go to immersiverepg.com. And if you want to help support the project where I can work on it more, there is a Patreon at patreon.com/immersiverepg. Anyway, the thing I want to show you is basically how do I eliminate more stuttering and how do I stop the game from being all stuttery. Let me demonstrate here. I have a small I have a button. I'm going to click it and it's going to load in 500 of these little balls here. And notice the frame rate here, it's 60, and when I click it, it will dip. So boom, it dipped down to 40 while adding these. And if you look at the code, it is, close this. Essentially, we just have a for loop. We go 500 times, we instantiate a ball, we add it to the scene, and then we give it a random position. You can just ignore that. And when I do that, let's do that again. You'll notice down here it measured the time and it was 170 milliseconds of blocking. So that's 10 frames of just the whole thing being frozen. Okay, you're saying typically what we would do in this situation is we would use call deferred to break it up so it's not blocking for 500. So let's do call deferred. And oh, look at that, it dipped again. Let's remove them all. Click it. Oh, it still dipped again. So what does the code look like there? It's literally the exact same, except whenever I put it all into a function lambda, and then I'm just calling it here, doing call deferred. So why is it skipping and stuttering? It should be not blocking, but it is. So the problem is it's creating 500 call deferred functions and loading them into the engine, and the engine's just running through all of them at once and calling them one after another, which skips. So the idea I had is, well, let's just make our own call deferred that doesn't do that. So now we have call throttled down here. Let me show that running. Okay, so here's normal, it blocks. So let's remove them all and then call throttled, and boom, look at that. It didn't block. Let's remove them all, call it, remove them all, call it, and it's not dropping frames. So what is it actually doing? Let me show this first. In the console down here, I have it printing. So essentially, what it's doing is it's breaking all of those up into one, two, three, four groups, and it's saying, let's just call as many as we can and measure the amount of time used. And then if we're going over budget and we're going to start to drop frames, let's skip to the next frame and then call the next ones, and then let's skip again and again. So instead of this taking, what was it, 160 milliseconds, we'll break it up and be like, okay, here we use 12 milliseconds, here the next one we use 12 milliseconds, the next one, and then 8. So that solves a lot of problems, and this is ridiculously useful. And I'm amazed that I'm surprised Godot's call deferred doesn't do this by default. Maybe now that I'm thinking about it, maybe we could make some sort of feature request or something to improve that, because I've seen a lot of people struggle with this, because just by doing this and breaking it up, so we say, oh, just use all of our call deferred, but then measure the amount of time, and if we're going to go over budget, just skip to the next frame and then use them up there, and then if we're going to go over budget, and then just keep doing that, and it spreads it out. So then we get this nice silky adding instead of this weird blocking or even more blocking. So let me explain how to add that. Essentially, um, let's see, we just have a function here, and then we have a list of our to deferred right here to call, and we have a while loop that just pops one off the stack, calls it here. You can just ignore the details. It calls it, and then it measures the time here. And if we haven't gone over time, we'll just keep going. Then we just go back up here, we pop another one off, we call it, and then if we're not over time, we do that. And then we just keep doing that. And if we're over time, we exit. And then this will get called again, and then we just do it again. We call it. If we're not over time, we call the next one, and we just keep doing that. So that's how we're able to do that by essentially replacing call deferred with call throttled. Um, and let me go into more detail. The code here, it's github.com/immersiverpg/example Godot throttle. You can use this. It's MIT licensed. Extremely useful. It saved me so much trouble by using this in my game, and it just completely eliminates almost all the stuttering by just having to worry about this. So pretty much wherever I'm saying call deferred, I can just say call throttle now. I'm going to go into more detail now. One of the downsides is I want to start running. Basically, Godot runs all of the deferred inside of the process function. If you have a custom, if you inside of the scene tree, it'll run them all inside of process. But we can also run them inside of physics process. So what I'm doing is I'm running a, where is it? General application run. Then you can set up a custom main loop here. So then I get control over exactly what code runs in all of the physics process. So it'll call this, and then it'll run the physics process for all of the child nodes in the scene tree. So all this is just to get the throttler, because this runs before all of the where is it? The singleton throttler is loaded. We have to do this to check. It's kind of a hack, but it works. So we get the throttler, and then once we got it, we just call run callables. So every iteration of physics process, we do this, and then we just do run callables, and which is just the function from earlier, or it's run callables. And when I want to load back in our game here, where we want to add our sphere to the scene, we just do throttler call throttled, and it's right here, which just adds it to a list. And we're using a mutex here because it's common for, if you have a background thread, if you want to run some code in the main thread, you just do call deferred, and it'll run that function in the main thread. So if we do it like this, we don't have to worry about where call throttled is called from. It could be from the main thread or a background thread or whatever, because it's just going to lock it here before putting anything into the stack here, and then we unlock it here inside of the main thread when we pop it off before we call it. So that means we can do this from main thread or background thread. And the only other real thing to worry about is the setup here. When our game starts, we have a ready function. So the thing is, every frame is, if we're doing 60 frames a second, is roughly 16 milliseconds is our budget. So then we have to say, well, what if one of the functions we call is longer than that? So we basically have a threshold for how much time is left. So if we start with 16 milliseconds, we call a function, we've got 10 left, we call another function, we've got 7 left, and then we call another function, and then we have only 5 left. We're like, okay, we only have 5 milliseconds left in our frame, so we don't want to run out of time. So let's just say the threshold is 5. If we have 5 left, let's skip to the next frame. So that's all this is. So all we have to do, I mean, if you don't understand it, you can just copy this code. Um, and then you should be able to use the throttler from then on. Um, and also, if you don't want to use this custom scene tree, I know maybe you don't want to do that to set this up. You could just replace this with what is it? Await, and then wait for the scene trees um, physics process, and then you won't need to worry about using this custom scene tree. So anyway, that is one um, small thing that I highly recommend you guys look into because it's extremely useful. I wish I knew about this technique like years ago. This code on the GitHub page is it's for Godot 4. It should work fine with Godot 4.1. And if you need to use Godot 3, it's not that big a deal. Only a couple things need to be changed. But anyway, I will upload this, and if you guys have any questions or anything, I've got a couple other videos I'm also working on. I should have out. Let me know. I will talk to you guys. Again, let me do a shout out here. Everything's at immersiverpg.com. We have a YouTube page where I put most of the videos, and there's backups on Rumble and Odyssey and all that. And the code is at github.com/immersiverpg. And if you want to help get anything done faster, give me more time to work on stuff, it's patreon.com/immersiverpg. I will talk to you guys later.